Okay, hello everybody. We're back. Um, Let me get the camera on for just a second. I'll say hello. And how y'all doing? Dr. Thomas Fernandez here again, and my lovely wife Diane. So today we're going to do lesson 2 in the algorithmic art class using C Sharp. Um, Mostly we're just going to do some cleanup on the code from yesterday. And I think I've improved the sound. I'm using a different headset. I don't know if you can see it, but it's a different headset. And I turned the mic down a little bit so we won't get quite as much noise. Anyway, back to it. Um, First thing you want to do is, let me close all versions of Windows Studio. I'm going to save that. Not a big deal. Okay, so if we go into Visual Studio, you can see all the little projects I have. What the code we worked on last time was this WFT 000. Where is that? Um, Here it is. WFT UT 000. So that was class 0 or class 1, whatever. In any case, I've copied this entire directory down to this directory. And so, and we'll talk a little bit about that, but you should be constantly backing up. And later, maybe we'll talk about using Git as a way of backing up. But when there's only one person on a project and you have enough hard drive space, you can just copy the entire directory. And you should probably also erase the bin and object directory so you're not wasting a lot of space. Anyway, if I open this directory where I've copied it to, everything is exactly the same. I've gotten too deep in the directory structure, and then there's an SLN file, and I'm going to double click on it. And that's going to open Microsoft Visual Studio. And this is the project that we were working on. Okay, so let's just run this real quick and take a look at some problems with this code, because the main thing we need to do before we can really get into some artwork, we need to clean this up. Deanna, can you turn the timer off? Okay, so we need to clean up the framework so that we're using a good framework. Now, when we click Do It here, you can see that, and if you remember, we're drawing 200 ellipses. All the code is here in this draw routine. And you see we have a for loop that goes from 0 up to 199. And each time through it gets a new random pen, a new random rectangle, and draws it as an ellipse. And then it invalidates it. And I mentioned in the last class that putting the invalidate here inside of this loop is really a mistake, because it's causing the window to be redisplayed each time. So in order to complete this little artwork, it's going to redraw the window 200 times. And that's partly why it's such a flicker monster. Now, I don't know how the flicker comes off in the video. Sometimes the video, because of the frame rate, may synchronize with the flicker. You may or may not see the flicker, but I guarantee you it's flickering. And to really see how bad it could be, Let's just say that instead of drawing 200 ellipses, we wanted to do a continuous dynamic artwork. So let's just make this 2 million ellipses. So it's going to draw the ellipse 2 million times. And now if we run this, oh, I got to close. This is the bug. This is the problem. When you see those warning errors, it's because you didn't close the last executable. So all I got to do is go over here and close the executable, and now it'll run just fine. Hopefully. You never know. Okay, it looks like it's running fine. But you can see that it really is just a continuous flicker monster. And I should just, before I go any further, I'd like to just tell everybody, if you have epilepsy or if there's a problem with flickering lights, you might want to just not look for the next 2 or 3 minutes. I'll tell you when I've got the flickering fixed. So, but for now, let's just take a look at this. So, flickering, and if I start another one, it's flickering too. And if I start another one, all three are flickering at different rates because the operating system is giving different amounts of computational effort to each of the different threads. Okay, this is starting to give me a headache, so I will shut this down. In any case, even as a dynamic art, to just have it flickering like that is unacceptable. And the primary cause of it is having this invalidate statement inside of this loop. And it means that each of these windows is going to be redrawn 2 million times just consistently. So we don't want to do that. So let's just take a look and see what the alternatives are. So I'm going to take the invalidate out of there, and I'm going to go up here, and I'm going to add another object here. So I'm going to add a timer, and I'm going to call it the invalidate timer, because I'm going to use that timer to regularly invalidate the screen. Now I've already got a problem here. If I go look at the error messages, it turns out there's a couple different types of timers. So there's a systems Windows form timer, and there's also a system threading timer. And what we want to do is we want to use the system Windows form timer. I think that's what we want to use. Probably either one would work. But since we're in Windows Forms, let's go ahead and use the timer. So we have to be more specific. We can't just say timer. We have to say system dot Windows dot forms dot timer. So now we've made it specific. So we shouldn't be confusing the compiler by it not being able to figure out what type of timer we have. Okay, so we've got a systems Windows form timer. And what a timer will do is it just sort of runs in the background and it goes off with a certain regularity. Now, just like the drawing thread, we have to create it. By the way, I noticed the drawing thread is kind of misspelled. So I'm going to go up here and correct the spelling. So it's only one R. And so, of course, that breaks the code everywhere drawing thread was used. But if I go over here to this little light bulb thing, I can click on it and it says rename drawing thread with 2 R's to drawing thread with 1 R. So I will click on that, and now it's renamed them all. Um, did we leave it running again? Let me just see. No, I think we're okay. Renaming field, restarting the application. I don't think the application is running, so it doesn't really matter. Um, but just like drawing thread, creating this thing called invalidate timer requires that we do a new with it. So I'm just going to say invalidate timer equals new systems windows form dot timer. Good. And there's 2 possible options, but we'll just use the one that takes no parameters, and that'll be fine. I don't know why it's fussing about this renaming the drawing thread. Let me just run this again. Oh. Okay, this is a great thing. So it's acting as if the program is still running. It says that the process cannot be accessed by the compiler because it's being used. Now, if you look here, if you look at my taskbar, it doesn't appear to be running. But remember that thread that had a loop with 2 million items in it? That thread is still running. So this can happen when you have a multi-threaded application, is that it can still be running and prevent the compiler from doing anything, but there's no way of getting to it easily. Well, it's not really that hard. Um, you can use the task manager, or a better thing is the process manager or process explorer. Let me see if I can find that. I know I have it somewhere. Let me go over here. Okay, so process explorer, and you can get that from the Microsoft Store for free. So if you run the process explorer, now if you want to find a specific process, you can just put in the search window, and I happen to know that the executable is called G00, or is it? Um, maybe not. Let's say um, WinForms. Yeah, there it is. So that's the executable. It's still running, even though it doesn't show up in the taskbar. Once you highlight it in the Process Explorer and press delete, it'll kill the process. And so now everything should run okay. And that is another problem that we're going to be fixing today. So we want to have the framework working really well, so that we can do our art without fussing with these little problems. Okay, so what I'm trying to do is I'm trying to set up a timer, and I'm going to say invalidate timer. Okay, I am going to need to start it, so I will go ahead and leave that in there. But I need to do something else first. I need to set the interval. So here I'm going to set the interval to, and this is in milliseconds. So I'll have it invalidate the screen every 100 milliseconds. Okay, so 10 times per second. So it's not a real high frame rate, but it's going to be better than doing it every time there's a new ellipse. Okay, so now let's see. I have to see. invalidate timer dot tick, I believe. Let me go. Yes, tick. This is where we specify the function that the timer is going to call 10 times per second. So we'll just say timer, okay. And here the syntax is a little weird. I think it's plus equals. Yes. So it's saying plus equals, and it's giving me a tab saying that I'll call this the invalidate timer tick. So I would go ahead and press the tab. And now it's going to let me press enter. I believe it's going to create the function. So let me go see if yeah, there it is. So what I did is I said invalidate timer tick plus equals, and then it put this code in, and by pressing tab twice, the compiler, or I should say the Visual Studio, creates this function. And this is the function that's going to be called 10 times per second. And in it, I'm just going to say invalidate. And so instead of doing it 2 million times, it's going to do it 10 times per second. In fact, I think I'll make it 5 times per second. So I'll put a 2 here. So every 200 milliseconds, it's going to invalidate the window. So let's see what happens when we compile this and run this. Okay, so we click do it. Okay, it's still a flicker monster, but it's not quite as bad. And the other thing you noticed is that if I start multiple windows, they're all going to flicker at the same rate. Okay, now I need to get rid of that for sure because that's not fun to watch. Now, if I go back to the designer for the art form, and it says it's loading the designer, okay, that's good. And then I go to properties, and it's a little slow. Let me close this and try again. Properties. Okay, so it's still setting up the properties. So I've noticed this with Visual Studio. When you first start up the designer, it takes a little while to get the properties thing working. Hopefully it'll work. Otherwise, I'm going to uh, pause this and wait for it to work. Oh, okay. Let me go back to the, okay, let me go back to the code, and then I'll click back to the Artform Designer, and now I'll click Properties. Okay, so now it's filled in the properties. A little slow sometimes. I don't know what the problem is. But we've got the properties here. And remember, you can either cluster them in groups. So here's like everything, accessibility is in one area and appearance is in another area. All the fonts are in another area. The behaviors in another area and so forth. But I know what I'm looking for. It's called double buffered. And here it is. And right now, the property for this window, Artform, of double buffered is considered false. Now, I'm just going to change it to true. Now, I'm just going to, it really doesn't matter. You have to just set double buffered to true in order to get rid of all the flicker. But what it does is when it's drawing to the window, it draws to another area of memory that's not being displayed. And that's the double buffering, is that it has two areas of memory. And when it draws to one, it shows the other. And then when it's done drawing to one, it flips the two so you don't see the flicker. Not important that you understand that. It's just important that you set double buffered for the form equal to true. And now, if we run this and click do it, okay, now it's still changing, but it's not flickering. It's not blinking with a white window and then the next image and white window, because when it does the drawing, it's doing it to an area of memory that's not being displayed, and then it just switches the two areas of memory. And this is just something you have to do to keep it from flickering. Also, because the invalidate runs for every instance of artform, they're all going to sort of have the same amount of blinkiness. And they're consistent. Like when we did it without this, when the invalidate was just inside the loop in the draw function, then one would show up more often. And now, I mean, if you do enough of this, then you'll eventually overload the CPU, depending, of course, on how many cores you have. This is a pretty old machine. This machine is about 7 years old, so it was pretty hot when I first got it, but and it still works fine. So in any case, you can see that all these different artworks are sort of blinking at the same rate, but not with the white screen. So we've gotten rid of the blinking monster, and we've also made it consistent. Now, what we haven't done is when I close this, I'm still not going to be able to make changes. I'm trying to think what. Okay, if I change the timer to be every 10 times per second, and then I recompile it, it's not going to work because it thinks the program's still running. We left that thread running. Now, we need to fix that because it's kind of a nuisance to have to keep going to the Process Explorer. I should have left it open. It's a nuisance to keep going back to the Process Explorer. And then I got to do find, filter processes. Then over here in this little box here, I have to put in the WF, and apparently it's the only process that begins with WF. You might have multiples here, but make sure that the one you kill is WF tutorial 000. By the way, we haven't changed the name of the executable. We only changed the name of the outermost directory. So the executable will still have the same name. I will highlight this and I will delete it, and that's kill that process. Now, we don't want to do this every time we run the program, and we might very well want to, instead of doing this for loop 10 million times, we might just say while true. So this will never end. This loop, this is an infinite loop, something that usually they teach you to avoid. But in this case, we want continuous animation in this art window. Now, how can we get it so that when the form ends, it'll kill all the threads. And there's a simple way of doing that. I'm just going to put a little air in here, space this out. So we set drawing thread, we set it to a new thread, we set the specification of the function that it's going to call as draw. We set 2 million bytes as the buffer in case we're going to do some recursion. We will do recursion. I'm not sure we'll get to it today, but we'll do some recursive art, and it's pretty cool. But then we started the thread. But what we want to do is we want to give the drawing thread another property, and we'll say dot is background thread, and we want to set that to true. So by setting the is background property to true, we've made this a thread that's closely attached to the form, runs in the background, and unless I'm mistaken, which does happen pretty often, now when we run this, and by the way, it should update more 10 times per second now instead of only 5 times per second. So when we run these, and again, there might be a point where it slows down a little, and that's because we've overloaded the number of cores that we have in our processor. But the point is that when I close all these windows, and by the way, I should point out, these are all child forms of this form here with the do it button. So when I close this form, they all close as well. And now, if I make another change to this, let me see if I can get 20 times per second. So I'm going to bring the timer interval down to 50. And now when I recompile it, it's got no problems. Because it's a background thread, when the form closes, the thread is killed off. So we've got this in better shape now. And I don't know if you can see, maybe slowing down a little as I open more windows. Yeah, they appear to be updating a little less frequently. By the way, when you set the timer interval, that doesn't guarantee that you'll have the timer go off every 50 milliseconds. It's just something that the CPU is going to try to do. And in this case, it's obviously doing it less than 50 milliseconds. Let me just do another little experiment here. If I maximize this window, okay, so we can see that it's maximized. Now, if you notice this, it's a little bit pixelated. And the reason it's pixelated is because it's drawing to a bitmap, and then it's expanding the bitmap to fill the screen. Now, I got a 4K monitor here, and so we set the bitmap. Let's see where we set the bitmap height and width. So they're only set to 600 and 400. We'll set them to 6,000 and 4,000. And you'll see that the resolution of the display, it's, let's see, what's happening? Did I get this? Oh, this time I did leave it running. It's not that the thread is running in the background. I didn't close the app. So let's go ahead and run it. And this time we're going to see sort of a higher resolution display. You can sort of see that. And of course, if I maximize it, you can see that the lines are thinner, because instead of drawing in a 600 by 400 bitmap, it's now drawing in a 6,000 by 4,000 bitmap. Now, this bitmap, it's already exceeding the size of the monitor. So it's kind of like downscaling it to put it in that window. Let me close this. But you can make this very high. And the reason you might make this thing very large, let's just say make this 16,000 and 12,000. Now that's a lot of pixels, but it should work just fine. Uh, and the size of this may depend on how much memory you have in your system. So I've got 64 meg of RAM, which I know is no longer a big deal, but it was 7 years ago when I first made this thing. And you can see that the lines are a little bit faint because as it downscales the bitmap to the 4K monitor, because the bitmap is 16,000 by 14 or 12,000. Now, why would you want to make the image that big? And there's a simple reason. Later, we're not probably not get to it today, but later we're going to get to code that will allow you to save the bitmap, uh, probably as a JPEG so that it's not too big, um, to a file. And then you can send that file to a printer and have a very high resolution, large display. I'm sorry, a large print. And there is a printer that I've been using called Spoonflower, and they do an excellent job of printing this, and they print it on cloth. And I've found that different types of cloth seem to work better, and we'll talk about that later. But it's interesting that Spoonflower charges less to print like a big yard, 36 inches by, I forget what it is, maybe 36 by 26. So it's kind of big. And I would stretch those onto wooden frames and beautiful artwork. The university where I worked, Florida Atlantic University, they have a whole bunch of my artwork on display, and we'll get to that later. We're not quite ready for that, and I'm going to take this down again. So I'm just gonna say 3,000 by 2,000 for now. That's plenty detailed enough. So let's run this at that resolution. And if I maximize the screen, you can see that the lines are very detailed and sharp. Okay, so I think we've sort of got this framework so that it's working pretty well. Let's just review real quickly. We set up a drawing thread that draws to a bitmap, and we set up a timer to set up regular intervals when the bitmap is going to be displayed in the window, the artform window. So if let's just do a quick review of the code. We created a bitmap. We've already set the resolution of the bitmap up here. We also associated the G bitmap, the graphics object, with the bitmap so that now we can use the G bitmap. It's a class that has all kinds of drawing functions in it, And when we draw to the G bitmap, it'll show up in the bitmap. We also set up a drawing thread so that the drawing can go on in the background. And we set the drawing thread to for the is background property to be true. This means that when the form closes, the thread is discontinued. And then we started that thread. Now, we also created a timer called invalidate timer, and we set its interval to 50 milliseconds. That might be a bit low. We might be better off just 100. And then we set a function to be associated with the timer that would be called every 100 milliseconds or 10 times per second. And then we started the timer. Just the same sort of logic that we used to start the background thread. This is the function that the invalidate timer is calling 10 times per second. And all it does is invalidate the form, which, if you remember, tells the operating system that that window has to be redrawn. And then the operating system will call the paint function. And let's go take a look at the paint function. This is the paint function. And all the paint function does is it calls a gdraw image. So it draws the image in the display. And these parameters here, display rectangle is the area of the window that can be drawn to. And what these parameters do is they will stretch the drawing to fit the window, regardless of what the dimensions of the bitmap are. And of course, we started the thread, and we associated the draw function in the constructor of the thread. We associated that thread with the draw function. And so now the draw function is what's going to do all the drawing. Okay, so that's the whole thing. Oh, we can get rid of this line. I don't like to leave commented lines in my code. I'll just take it out. And we can see what the draw function does is, oh, and by the way, the thread will keep running until this function ends. But this function has an infinite loop. And so it's going to keep running forever. So it's going to keep getting random pens, random rectangles, and then drawing those ellipses. So if you want to, I'll post this code just like I did the last one. And if you want to play around with this function, for example, now last time it was draw a rectangle, we changed it to draw ellipse. Let's change it to draw a rectangle. And now we can run it again. And this time, instead of drawing ellipses, it draws rectangles. I don't know how great that is, but it's mildly interesting. I could sit and watch that for maybe about 5 seconds. But the whole point is that we've got the whole system is set up so that an artist will only need to write this one function, and the artwork will be in this function. Now, remember last time we had that bug with the get random rectangle? I think I'm going to change the code so that it only uses floating point values instead of using integers. And the reason for that is that as we do artwork, we may want to do some mathematical operations, sine functions, cosine functions, stuff like that, to get some interesting artwork. And of course, a lot of those functions don't work on integers. So I'll probably be changing this to make it use floating point numbers. Um, I am going to I'm just gonna change the art program. I'm just gonna change the draw function to do something a little different. So I'm gonna go ahead. Okay, there used to be a button up here that I could comment out everything, but the new version I don't see it. I'm sure there's some way you can configure the interface to put that back up. There is a thing, if you do Shift Alt, you make the cursor be multi-line, and then you can type things on more than one line. So I'm going to comment all that out just for now. And let's see. I'm going to make this thing. I'm going to make it pick a point. So there is an object that we use for drawing called a point F. You get that with a capital F. And it just means that it's a floating point, and it has two values, X and Y, and those specify where on the screen it is. So I'm going to say that I want point F. I'm just going to call it P1, and I'm going to make that point equal to, and then I'm going to just say G dot get random point F. Okay, so I'm going to make that a function that will get me a random point F. Now I am going to send it the B width and also the B height. So it'll give me a random point inside the bitmap. Now this is an important concept in programming, is that should I stop now and go write this get random point function, or should I keep coding? Now, what I should do is I should concentrate on what I'm doing here and not get distracted down deeper into my code. So I'll just assume that this get random point F is going to work perfect, and I'm going to keep this with the same logic here. Now, I think I'm going to do something else actually. Well, let's leave it at that. Okay, so now here I'm going to say point F P2 equals G dot get random point F, and I want this to be another point that's within the bitmap. So I will add those two parameters again. Now, I'm still going to need a pen, so let me take the comment off of this line. But now all I'm going to do is draw a line. So I'm going to say G bitmap dot draw a line. Okay, I still need a pen, but I'm going to draw it between points P1 and P2. Okay, so I'm going to leave these other two lines uncommented in case you want to play with that. but I'm just showing what you can do to create a new artwork with the system. All I have to do is change the draw function, and I'm getting a completely different artwork. And let's think about what this is going to do. It's going to take a random point, and that's outside of the while loop. Then it's going to take random points inside the while loop. That's the P2. Then it's going to take a random colored pen, and then it's going to draw a line between P1 and P2. Now, P1 is not going to change, but each time through the loop, I'm going to get a different random point. Now, let me go and write this function. If I highlight the function, and I go over here to the little light bulb thing, and I can select generate the get random point function. Now it's not here. You can look for it here, but it doesn't create it here because we said it was going to be in G. So if I press F12, it'll jump me over to the function, and here it is. It's a function that returns the point F, and it takes as an argument the B width and the B height. And again, it throws the exception that it was not implemented, but I'm going to implement it now so I can get rid of that. So I'm just going to say return new point F, and I believe the constructor for point F will allow me to just specify well, now it gets a little complicated, so I'm going to make a new function. See, whenever things get complicated, I try to push them down into another function. So I'm going to say get rand f, a random floating point value. No. I'm going to say get rand f. It keeps trying to fix it. I think if I insist, it'll let me get away with it. So I'm going to have a random floating point value that's within range of B width, comma, and a get random f. Ha, still trying to get a random point. The problem with the code completion is sometimes it's too smart, but I'm going to say B height here. And that'll close the constructor in the semicolon. The trouble is I don't have a function get random f. So if I go over here to the little light bulb thingy and click on it, it'll say generate method get random f. Okay, and here it is. I think I'm going to change the name of the variable from B height to just max. I guess integer is okay. Would actually make more sense to make it a float, and it can automatically cast between an integer and a float. And now it gets a little tricky here, but I'll step you through it. So I'm going to have a float value called result. And it's going to be set equal to, remember, we need the random number generator. Now, random numbers, getting random numbers with integers is a little different with floating point. In fact, it doesn't do anything with floating points. It'll only work with doubles. So I will have to say rand dot next double. Okay. Now it's already figured out what I want to do. So what happens when you get a next double, it doesn't limit it. It gives a value between 0 up to but not including 1. So what we're going to do is we're going to multiply that times max. And so that'll give us a value between 0 up to but not including max. So that should do exactly what we want. I think the code is ready to go. Always a good idea to just check the error list. Oh, so I got some errors. So it doesn't have a function for get random point because I said get random point f. So that fixes that error. Get random f float. Not all code returns a value. Okay. So if I look at this function, I really shouldn't call it result. Oh, by the way, yeah, it's going to require a cast to float because it won't just go from double to float. So I'm going to put parentheses around this whole expression and put a float cast operator in front of it. Okay, and then of course that puts it in the variable and I have to return result. It's a convention of mine to very often name the thing that's returned by the function. If I create a variable that's going to be returned, I call that value result because it's the result of the function. And now if I look down under errors, I have 0 errors and 0 warnings. So the thing will probably compile and maybe even run. Oh, by the way, this is still in debug mode from that problem I had last time. So I'm going to change it to release. Release should run faster than debug, depending on if it's down by hardware, it may not make any difference. Okay, so remember what the draw function did? It picked a random point. In that case, it's this sort of the center of this starburst. And then if I have another one, it runs. And notice they both run kind of the same speed. And another one. By the way, if they don't run the same speed, the operating system will give preference to whichever window is activated. See how the top border here of this window is a darker color? That's because it's the activated window. And if I come over here and activate this window, I don't think it's making any difference in this case, but it might in some cases. So the active window will get a priority in terms of computer resources being assigned to it. This makes the whole system seem a little snappier because the window that you're working on is getting more computational resources than the other windows that are running in the background. Okay, so last class went really wrong because, I should say, well, it went wrong, but it also went long. It actually didn't go wrong. There was a bug, and you saw me figure out how to fix the bug. This is an important part of programming, is to not get frustrated, work your way down, solve problems. Code doesn't always run exactly the way you wanted it to. It always runs exactly the way you said for it to do, but the way you said for it to do and the way you wanted it to do or the way you expected it to do may be different. And when that occurs, it's a bug. So we did solve the bug, and so I think that was a good experience. I've shown how by just changing this one function draw, I changed it so that I took out these other lines, and now it no longer draws the ellipses, but it draws that kind of that starburst pattern. Picks a random point. Oh, if each time we run it, it should. Uh, okay, so here's a good example. Here the point was near the top of the screen, so that created that pattern. And I don't know where that went. Okay, but if I run it again, this time it picked the first point that was closer to the center of the screen. Now, this thing get random color, we're going to play around with colors. We might want to just have different shades of blue. That might be more interesting than than in fact. Well, no, this class has gone long enough. The last class went way too long, so I'm going to wrap this up. And next time we'll do some playing around with colors and maybe a little bit of recursion, and we'll see how a little bit of code can make very elaborate patterns. Anyway, guys, have a great day. I'm going to put the camera back on, and I'll say goodbye. So, guys, have a great day, and I'll see you in the next class. Or I should say, you'll see me in the next class. Anyway, have a great day. Bye-bye.